Dr. Shalev, welcome to the show. How are you?
Very good, thank you. How are you?
I'm doing all right. I want to talk with you about artificial intelligence and using that to read diagnostic imaging. But before we do that, just kind of give us a brief rundown of who you are, of Dyad Medical, and then we'll kind of go from there.
Well, as we said before the show, I'm essentially a computer scientist, who was involved in image analysis most of my career. Recently, or in the last, let's say, 10 years, I was exposed to the lag of healthcare industry behind what I call technology.
Yeah.
So I thought it would be really a good idea to bring everybody to the same starting point with the development of the cloud technology, deep learning and AI and image processing and so forth. So this is what we do. At Dyad Medical, we develop a platform which focuses on analysis of cardiac medical images. The reason I'm emphasizing cardiac is because right now we are an organ-specific platform rather than the general image analysis platform.
Yeah. So it's specifically about the heart, about cardiology. And before you said there were four types of images or diagnostic images that y'all analyze. What are those?
Right. So these are modalities, what they refer to as modalities. So we support cardiac MRI or what they call CMR, cardiac CT, IV OCT, or intravascular imaging using near infrared light, and also echocardiograms.
Okay. Cool deal. So how does this work? I guess somebody goes to a hospital, they might have an echo done or an IVOCT done, and then what? The physician or the radiologist can upload the images or the data into the platform, and then what happens?
Well, it depends on the settings. There are
Okay.
two main settings. One is research settings, where they do clinical study, post-processing, and people
Uh-huh.
they essentially sit in front of the computer and they load images that they already have in their storage. The clinical settings, which you are describing, we are essentially within their current workflow. We do
Okay.
not interfere with their current workflow. The images are being scanned and they're being sent by their system to their storage, which can be a PACS or EMR or EHR system. And we have a piece of software which we call a watchdog, essentially querying the PACS system when there is a new study that we can analyze. Once we identify a study that we can analyze, we analyze it, we send back the result to the hospital. Now, the doctor does not really have to do anything different from what they do today, but they do have an indication that there is insight or analysis results from Dyad Medical. They can choose to open it, or they can simply choose to select the report automatically generated by Dyad Medical, or they can even select to ignore it completely. That's their choice. Really, this emphasizes the concept that we do not replace them. We just support them and give them a tool to maybe potentially accelerate their work and make it slightly more efficient.
Yeah. Yeah. Every time you talk about technology in healthcare, it's funny. We've done a lot of interviews with a lot of folks that are developing platforms like this, and the number one thing they all say is, "We're not replacing clinicians. We're not replacing clinicians." So, yeah. Okay. So this system is automatic. The videos or the images are getting uploaded. They're getting scanned. A little note or a little notification is going off to the doctor for them to either review or see the report that's coming out. How is this being done? I'm assuming you said you've built an artificial intelligence platform. Is it run by an algorithm? I think we were talking before about how it's always learning, right, with the data that's coming in.
Right.
Tell us a little bit about that.
Okay, so essentially there is this concept called backend or front end, right? The
Uh-huh.
front end is what the user is interacting with, and the backend, which in our case runs on AWS today, it gets the messages from the front end. So let's say there is a study being scanned. We already trained our system in such a way that as soon as we identify a new study, we can analyze it for whatever parameter the clinicians are interested in.
Yeah.
Once we have the results, we get rid of the images. We do not keep them. And then we send the results back to the hospital for review and for further analysis if they choose to. Over time, obviously we can select a few, let's say, higher end candidates who know what they do, and we can incorporate their input into the additional training of our system to improve our results. And this is something that can take place anytime we choose to do it.
Yeah. And then I'm assuming it's also collecting data and all that from the research studies, right? You've got a bunch of people that have all these images on file, and they've been loading them up there, and it's
Right.
kind of just increasing the speed at which the system can analyze, right?
Exactly. Not only this, we can even enable a company or a hospital to essentially do what we call a batch processing. Let's say they have, I don't know, 5,000 data sets of some retrospective study that they did at some point. They can, using our system, they can run analysis on all 5,000 at once without really human intervention. After some time, they get the results of all 5,000 patients. So this is for research purposes, and obviously the conclusion can be analyzed by them.
Yeah.
We essentially tell them what we see on those images. We do not make any recommendations for treatment at this point.
Yeah. So it's not so much interpretation, it's just this is what the image has been analyzed, and this is the what we see in it, right?
Exactly, that's what it contains.
Yeah. Awesome. Well, I know we were talking before how you started off in adults, started basically building this thing, right? But now you're focusing a little bit more on the pediatric side. Tell me a little bit about one, the challenge in developing an artificial intelligence platform that's going to analyze pediatric cardiology images or modalities, and kind of how you kind of crosswalked it or walked it backwards to get there.
Right. So the concept with deep learning, especially when you train a system, train quote unquote, you train a system, essentially you input to it a few images, and then what the expert told you about those images. This is what they call supervised learning, right?
Yeah.
And now to do a decent analysis and train a decent system, you need a few thousand studies to do the training. However, with the children or pediatrics, you don't have so many images or studies, specifically not from one single hospital. You would need to collect from multiple hospitals. Now, with children, you have something which is even further makes it even more difficult. A 6 months, a year old baby does not have the same heart as a 5-year-old or a
Yeah.
16-year-old, right? So, yes, we do say pediatrics, 0 to 18, but you really have to divide it even further beyond those 18 years, right? So it depends on how old the child is. So what we do is we connected with a few pediatric hospitals in the world. They gave us some data. When I say gave, I mean sold us some data. We had the experts annotate those data so we can train an initial engine or initial AI engine. And now we are exploring the concept of federated learning, where we can retrain the system and improve it over time. And this is really a really good approach, because with the federated learning, you don't really the hospital does not necessarily have to share their data, which means the HIPAA compliance is being kept in place. So there is no issue of a PHI or personal health information sharing with us. And hopefully we'll get a very good results to support all those unfortunately few pediatric cardiologists that actually do treat small children.
Yeah. How long does it typically take to get one of those? You said you have to train this engine at the beginning. How long does it typically take to do that so that the engine itself is producing or analyzing something and coming up with a report that's serviceable?
Well, it depends on two parameters. One is how many data sets you have. The other one
Uh,
is what kind of hardware you use.
yeah.
We have an extremely powerful, with multiple GPUs, NVIDIA system, essentially with many GPUs, lots of memory, and which can train essentially use a few tens of thousands of studies that we already have. And training with our platform and our data set can take maybe half a day.
Oh, holy smokes! So not long at all. When you're talking like training this data thing, I'm thinking like, holy smokes, is it taking you like 6 months, a year to
Well,
analyze all the data initially?
With a personal computer that people work in the office, normally it can take 3-4 weeks.
Yeah.
You click run and then you go take a vacation. So, but with our system, it's really fast. And by the way, there are cloud systems that enable you to do this even faster. The problem is the cost, so we prefer to keep it in house.
Yeah. Okay. Um, I'm trying to think of like, us- so assuming that let's say you got the data set, you started building this initial learning or training. Um, it's supervised learning, right? So I'm assuming you have folks on staff or had folks on staff that were kind of reviewing the output that the machine was creating or that the system was putting out and basically verifying it for efficacy and for accuracy and all that kind of stuff, right?
Right, exactly. So it's they're not on staff. We do have a few subcontractors that do the work. We devised a few methods, statistical methods, to verify the level of their work and make sure that they do the right,
Uh-huh.
you know, they perform their job very quickly. It's a few tens of what we call experts.
Yeah.
Now, we also make sure that those experts have various varying level of skill levels. So what we can, this is how we improve the generalization of our system. Various levels of various skill levels of the annotators, plus multiple sources of those studies. It's not every cardiac MRI machine outputs the same level of the same quality of image. You know, GE machine has a very different looking image from I don't know, Siemens.
Yeah.
Uh, Echocardiogram, a handheld device, has a very different image quality from, let's say, a bedside echocardiogram device. So we make this mix of levels and skill levels, and this is how we train the system. Yeah.
Yeah. So it's almost essentially like running a statistical analysis, right? Like you're almost like you're doing your own research study, and you're coming out with a confidence interval at the end, right?
Right, right. And by the way, in many cases we cancel experts, what we call experts. When I say cancel, I mean we let them go. I'll give you an example which is really obvious to understand. Let's say I give an expert 10 images, but I duplicated the 10 images, and now I have 20, and I give this person all 20 to annotate. So if we realize that this expert did not agree with himself or herself uh, at a higher level, meaning they disagree with themselves
Yeah.
at enough higher level, then we essentially say, listen, you're not good enough for us because we need you to agree with yourself before we actually use your data to train our system. So that's one measure that we use to, for example, to make sure that the work is done at the highest level possible.
Yeah. That's interesting. Are there like standards out there that you can like when you're developing this that a benchmark? Okay, we're going to give whatever however many data sets to a professional or clinician. They're going to have it's going to be duplicated. Like, is there a percentage number that's out there that's like, okay, this is a good benchmark? If they're 95% consistent, then that's good.
Well, I think 95% is kind of an agreed upon number by the statisticians.
Uh huh.
We try to be on the 98 and above percent because we essentially say that there is nothing there that there are some things that open to interpretation, but before we do this, we'll give a very detailed guideline. We essentially use the guideline of the respective society.
Yeah.
They have to follow these guidelines. If they don't do it well enough, or if they don't really understand it, or if they do not a very good job, in our opinion, 98% is a better measure. Although 95%, some people see it as a statistically good enough. So
Yeah. Um, I mean, that's interesting. So, um, you've got the machine itself or the system itself is analyzing this data. Is I'm assuming because it's just analyzing raw information that's coming from the system, it's not taking it like there is no input for the account of like, let's say this patient is a 34-year-old morbidly obese patient versus another patient who's relatively healthy and hasn't had any issues, but now they're presenting with some cardiac dysfunction. You leave all of that to the clinicians to figure out, and the machine learning is kind of just doing the analysis of the images, or is there space for them to take into account this is a normal study, quote unquote, typical study, except for given these extenuating circumstances in this patient's data set or whatever?
We do take this into account in the training. This is what we call a quote unquote feature.
Uh huh.
However, in our system, we allow them to do to configure their preferences in such a way that they can make a decision based on one of these parameters. One of the biggest or greatest use of this concept that we developed in the company is that let's say they wanted to be notified of something which is out of the ordinary according to some standard.
Uh huh.
Let's say it can be an American standard, can be Chinese standard. Each one of them can have their own standard depending on the population. So yes, we do train our system taking these into account, but the user may ignore or take it into account if they choose to, or they can modify it and select their own standard. Uh, in the USA, it can be the ASE, the American Society of Echocardiography. In China, they have a Chinese version of the same society. So each one of them can have their own table, and our system allows configuration for this.
Okay. So, and this system, if I understand it correctly, is just automatically like a physician isn't selecting, John Smith, patient A, to get this their cardio. Let's say it's an EKG read by the platform. Everything that they're doing is automatically getting read, getting analyzed, and then
Right.
if something trips, they get a little notification, right?
Right, and they can select how they want to be notified because there is at some point there is a notification fatigue by doctors.
Yeah.
Every system get their own. So what we try to minimize it, and essentially of course, they can select to get an SMS or an email, but that's too much, I think.
Yeah.
So within the system, we do prioritization in such a way that we tell them, listen, when you log in, here are those that you wanted to be notified about, and they appear in red. We also have an indication in case somebody doesn't see colors clearly. So this is what we call prioritization or work
Uh-huh.
list. Yeah.
Yeah. And I guess each clinician or each organization gets to set up their own prioritization,
Right.
right?
Right. Exactly. Right.
Alrighty. And I guess the other piece of this making it work is that the fact that it's not like a hard drive issue, right? Or software on like a computer. It's a cloud based, which means it can be used basically from anywhere, right? So any hospital or imaging center that's got an internet connection can use it, correct? Or are there different requirements? Like you need to have a certain
All you need,
bandwidth or whatever.
you're absolutely right. All you need is a browser, really,
Okay.
because we are a very small footprint type application. If you have a browser, HTML5, that's enough. We don't really care if you have an iPad or a gaming platform or a gaming desktop. Anything
Uh-huh.
that has a browser can work without any problem. Yes.
And have y'all, the academic in me is jumping out now. So have y'all taken the analyses from the platform itself and then compared that to like a cohort of expert clinicians and kind of seen where it stands on the level of accuracy, or whether there's, I guess, discrepancy between clinicians, or if the analyses are more accurate?
Right. Yeah. So this is what we refer to as a held out set.
Uh-huh.
Essentially, it's a set that some experts with plural experts analyzed and made treatment decision in the past at some point, and we run our system on the same data, and we compare our results to theirs. And this is, by the way, how we submit our FDA clearance application, essentially showing them that we are just as good as those who already did it in the past at a higher enough performance parameter.
Yeah. So tell me about this FDA clearance, and what's the process? I'm assuming you've got to do this, or you've got to do this experiment or this study, if you will, to show that the system is producing at least at a standard level according to experts. How long does this process take? all of that kind of stuff. Walk me through getting the FDA clearances.
Okay, so FDA clearance is it's quite a tedious
Yeah.
process to be truthful.
Yeah.
It depends how many parameters we'd like to compare. I can come up with one single parameter. It may take 2 months. If I have 10, then it may much longer. Keep in mind that the more more parameters or indices, what they call indices, you need more data to do the proof work.
Yeah.
Essentially, compared to actual results from other devices. This process, depending on the resources that we have, we can today we can do in roughly 3 to 4 months. Again, depending on data availability, if we already have the data in hand or not. That's one of the major parameters that impact the length of time that it takes. And that's really about it. All the rest of the FDA submission has to do with the inner works of the company,
Yeah.
how we do QA, how we document stuff, and so on.
Yeah. Yeah. It just seems like anybody that is trying to bring something into the healthcare market. This is going to be U.S. specific here, but it seems like the FDA, while doing its job to be very thorough and make sure that we're not harming patients, it's a lot of it's a lot of paperwork, a lot of waiting, a lot of analysis, right?
Right, it's a lot of analysis too, and to be honest, the issue of analysis is completely justified.
Yeah.
I support them. I mean, you do have to show that you're good enough, or at least as
That you're
good
not
as
going to
you
harm
can.
anybody, right?
Right, right. So we are what you would call 510(k) class 2 device, and we have to show it. All right, we can't just make the claim. So that's what we do. The issue of documentation, yes, it's a pain. I can't deny it, but I don't fully recognize its necessity.
Yeah. Yeah, no, it's great. It's interesting to hear people that have gone through like they've either gone through the FDA and now they're on the other side. They've got their clearance and like, when we cleared that hurdle, we got over it. Now we can get on to seeing patients and stuff like that. Well, Dr. Shalev, thanks so much for being on the show. I always ask folks if there's one or two main points that you'd want people to walk away with from the episode about cardiac imaging or even about Dyad Medical, what would they be?
Well, I would like people to remember it's really hard to communicate this notion of being an organ specific platform.
Yeah.
Organ specific, really, over time, we develop what you call domain expertise. So,
Uh-huh.
yes, I'm a computer scientist, but over time, because I focus on the heart and not the brain, it's important to remember that this is a huge advantage. Yes, I've heard about companies that do deep learning in a whole bunch of fields, but it's extremely difficult to scale this way, especially for a startup company. So that's one thing that I'd like people to remember, the issue of organ-specific solution. In other words, keep in mind, 50% of the world does not have access to expertise in diagnostic. Being on the web essentially opens the world for those who don't have access. I know that people like to talk about third world countries that do not have access. For example, in Boston, in a single hospital, you have about 150 radiologists, and the population of Boston is about 700,000 people. In Liberia, they have 5 million people population, and they have 2 radiologists, right?
Holy smokes.
So
Yeah.
it does not make any sense. However, there is a hidden problem here. Even in rural areas in the US, they don't necessarily have access to higher level diagnostic. What I'm offering is if you have an internet connection, you essentially have an immediately available second opinion of experts
Yeah.
available to you. It doesn't mean you have to go buy it. It just means that it's available for you to consult with in case you need yet another opinion for whatever diagnostic you make.
Yeah, that's interesting. I think that's one thing that's become more and more apparent over the last probably decade, maybe 2 decades, when technology has been exploding, is that it really does. The options are endless. So taking the time to really specialize is really where you get to see the power of that technology, right? If you're deep focused on this one, like you said, in this one organ, you're probably going to be able to be light years ahead of somebody that's trying to do the heart and the brain and the kidneys and the liver and all kinds of stuff. At least, like you said, in a way that's scalable and sustainable. And
Yeah.
that statistic about the availability of expert radiologists is crazy to me. 50%. So, well, Dr. Shalev, where can people find out more about you, about Dyad Medical? I'm assuming there's a link they can go to and get a demo or something, right?
Right, right. So on our website, diadmed.com, essentially you can see who we are. You can contact us through an email link there that you have. We tend to respond to these very, very quickly. And that's how they can communicate with the company. They can also communicate with me through LinkedIn, Ronny Shalev at LinkedIn. That's really easy to do, and some people have done this before. So
Cool deal. All right. Well, Dr. Shalev, thank you very much. Have a good one.
thank you very much. You too.